So we're going to start with the number line, okay, where your segments, where the points have just one single coordinate. Okay, again, we talked about this back in section 1 too, but don't forget, if there's nothing on top of the two letters, that means I'm looking for a distance. I'm looking for a number. Okay, this one says that segment AB, this one is the distance from A to B. Okay, or the length of that segment. Remember, they go hand in hand. The length of the segment and the distance from the two endpoints is exactly the same. Okay. All right, so we're going to plot these points. So I gave you a number line. So at negative 11 is A, B is negative 5, C is negative 1, A is 3, E is 6, okay. Okay, we should label them with the letters. All right, so I'm going to give you a minute here. I want you guys to find these lengths from A to B, B to C, D to E, E to F. Count the spaces you got to move to get to the next letter. Did we get these? A to B is 6 jumps, B to C is 4 jumps, D to E is 3 jumps, and E to F is 4 jumps? Yes? Okay. Now, here's my question to you. This is super easy, isn't it? I give you a number, you figure out how many jump shifts to get to the next number. What if I gave you the distance between 123 and negative 57? Are you going to draw me a number line that goes from negative 57 all the way out to positive 123? No. That would be ridiculous. So there has to be another way to do this. So let's see. Is there something we can do with our numbers to get the answer besides drawing? Subtract. I like it. So she's saying she saw we had negative 11 and negative 5. If we subtract them, I actually get negative 6, but it's close, right? Hugo, you have an idea?
I have an answer.
What's your answer?
180 units away.
That is correct. Okay. And what operation did you use to do that?
Well, I multiplied 57 by negative 1 to get a positive 57, then I added the two together.
Yeah, you could do that. Very good. If we continue along that trend we were talking about with subtracting, this was the coordinate for A, this was the coordinate for B. We subtracted them, we got negative 6, which is close, right? Just the wrong sign. Over here, if we do B to C, we have negative 5 minus negative 1, which again, when I subtract them, it gets me negative 4, so it's just the wrong sign. How do we get rid of negative signs besides multiplying by negative 1? What's that other thing we can use? Give you a hint, it looks like this. Begins with an A.
Absolute value.
There you go, absolute value. Okay, so what we can do is subtract them and then take the absolute value. Now, why would we want to do absolute value? Let me ask you this question. We're talking about a distance, right? When was the last time you said, I'm going to go travel negative 54 miles down to the beach? Would you ever say that? No. Okay? Are distances ever negative? No. It doesn't matter whether you're going there or coming back. You're just going to use the same number, 54 miles to the beach, 54 miles home. Neither way is it ever negative. That's why our distances are always going to be positive. What makes everything positive? The good old absolute value sign. Okay, so since it has to be a positive number, okay, if we want to find the distance between 2 points on a number line, we take the little coordinate for A, subtract the coordinate for B, and make them positive by adding the absolute value. Okay? I will tell you, for whatever reason, every time I teach this, and then I teach the distance formula, everybody forgets this one. The easier one. It's very simple. Subtract, make it positive. Subtract, make it positive. I will ask you this on tests. I will ask you it on quizzes. It'll show up on your midterm. Know this formula. Love this formula. It's easy. Just remember to subtract. Okay? So let's try it. Here's my points. X is 12, Y is negative 5, Z is 8. Find the following. Now again, these are pretty close. I could draw a number line, but why waste my time? I have a formula. I'm going to take them and subtract them. So if X is 12 and Y is negative 5, right? I subtract the coordinates and take the absolute value. What do I get? 17. The double negative will make it positive. Okay, I'll do Y and Z. Y is negative 5, Z is 8. Again, I want to just subtract them. What do I get? 13. I'll get negative 13 when I subtract them, and the absolute value of negative 13 is positive 13. Don't forget as well, the absolute value of a positive number is still positive. Do you know what the actual definition of an absolute value is? No. And that's why people make that mistake. Absolute value really means how far are you away from 0 on the number line. So it doesn't matter, okay, if you have your number line. Here's my 0. If you have positive 2 or negative 2, I know the signs are the different. It's just kind of basically giving you a direction. Isn't the distance between 0 and 2, 2? And the distance between negative 2 and 0, 2 as well? Right, that's why it's always positive. So it doesn't matter if you absolute value a negative or a positive, the answer is positive. All right, next word, midpoint. When you hear the word midpoint, what word do you think of?
Middle.
Middle. Okay, that's exactly what it is. The midpoint is the middle point. Okay, it's the point that's halfway between the two endpoints. Easy as that. What the midpoint does is it cuts this segment into two congruent pieces. Okay, if you want to see what a drawing would look like, to know that, say, M is my midpoint of this segment, I would see tick marks there. Then I know for sure it is exactly in the middle because the distance from A to my midpoint is the same as the distance from B to my midpoint. And that's how you would display a midpoint. Okay, on the graph below, we're going to plot these points. We got W and Z. All right, so W is negative 10, Z is 6. Okay, and what I want to do is locate the midpoint. So what are your suggestions to find the point in the middle? Hugo?
Count the numbers between W and Z and then divide by 2.
So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. There's 16, right? I have to jump 16 times, so the middle would be 8. Now remember, the answer's not 8, it's 8 jumps, right? So let's do 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So it looks like it's going to be here, and we can double check, do my counts the other way. 3, 4, 5, 6, 7, 8. Yep, this is my midpoint. Okay, there's my midpoint. I labeled it in. Again, here comes the question. If I give you that 123 and negative 57, are you going to draw me and count to the middle? No. There's got to be a different way. Does anybody know an easier way without the drawing that we could find the middle of two numbers? What do you think? Right, and what is that called? Begins with an A. So he says I should take my two numbers, add them, and divide them by 2. So that's -4 divided by 2, and it does work. What's that called? What happens when you get two tests, and your first test is a 90 and your second test is 100? There you go, you average, okay? It's the average of the two numbers. Okay, it'll always find you the middle. Okay, just like if you had two tests, you average them together to figure out what your average grade is. Okay. All right, so to find the coordinate of the midpoint of a number line, you find the average of the endpoints. All right, so that's pretty easy. We're all pretty good at averaging. We did that back while in middle school, I think. All right, so here we go. Using the same points we did before, x, y, and z, I want to find the midpoints of the segments. So to find the midpoint, it says, take your endpoints and add them. So 12 plus -5 and divide it by 2. So 12 plus -5 is 7. Does anybody know what 7 divided by 2 is?
3.5.
There you go, very good. Okay, and then why does he do the same thing? Add them and divide by 2. So that gives me -3 divided by 2, which is -1.5. Okay. So to recap, if I want to find the distance, I'm going to subtract them, make them positive. If I want to find the middle point or midpoint, I'm going to look for the average. Okay? But think about in algebra, you didn't always just get one coordinate, right? You guys moved on to the coordinate plane, okay, where you get an x coordinate and a y coordinate. So what happens if my lines have an x coordinate and a y coordinate? That changes things up a little bit. All right, so let's see what we can do here. So we're going to graph these segments. So W is 2, 4. One, 2, 1, 2, 3, 4. Here's W, and X is 5, 4. Okay, R is 1 down 3, and V is 1 up 1, 2, 3, 7. I'm going to connect them. There's one segment. There's another segment. And these are pretty easy to find the distances, right? If I want to find the distance from W to X, what am I going to do? What do I do? You just count. What do I get? 3. And I can do the same thing for RV, can't I? I can just count. When I count, what do I get? 10. Now let's look at the third segment I'm going to ask you to graph. We have HK, so H, okay, is -6. 6 up 3. And K is -1, 0. Huh. What's different with this segment compared to the other ones? You got? Right. It's not a straight vertical or horizontal line. Now it's diagonal. Can I count going across the diagonal? I mean, like, this is a nice whole one, but, like, is that a whole box right there? Anybody have a thought?
You go across.
Okay, so you're saying go this way and this way. Yep, I could do that. All right, so if I go down here, that's 1, 2, 3, right? And then I go over here, that's 1, 2, 3, 4, 5. So does that mean my answer is 8? Here you go. Add them and divide by 2? Not exactly. Does anybody know what shape that is? It's a triangle. What kind of a triangle? A right triangle. Do you guys remember how to find the hypotenuse on a right triangle? It's a lovely theorem with an A, a B, and a C. I know you want. Is this look familiar? Yes, no? Pythagorean theorem. You could do that and get 3 squared, which is 9, plus 5 squared, which is 25. That's going to equal my c squared. Right, so that gives me 36. No, I lied, 34. Is equal to c squared, right? And then I would square root it, so it's whatever the square root of 34 is, and you could just use your calculator for that. Again, every time I give you points, are you going to plot them on a grid and draw me the triangle and do all that work? No, so there's got to be an easier way. It's called our good old distance formula. Okay, the distance formula is essentially a manipulation of the Pythagorean theorem. But using this formula is a lot easier than having to draw it out each time. Okay, see how this is squared? And it's the x coordinates. That's basically this, finding 5, right? Subtracting to find my distance. And this is like finding my 3, okay, by subtracting my y coordinates. And we took a square root at the end, right? And that's where this comes from. So from now on, that's what we're going to use. Just plug this stuff into a formula, hit your calculator, you're good to go. All right, so now we're going to find it using the distance formula and see that it's also equal to the square root of 34. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Might look a little more complicated than it is. The easy thing to do is label your points. Remember, each point contains an x and a y, and the x's always go first because x comes first in the alphabet. Call one of them point 1 and give them little 1s. Call one of them point 2 and give them little 2s. And then take them and plug them right in. So x2 is -1, x1 is -6. Now be careful. I need to see the minus sign and the negative sign that goes with the 6. Okay, I should have 2 negatives, not just 1. Squared plus 0 minus 3 squared. And so that gives me 5 squared plus -3 squared. Now here's another place where I see people make mistakes. What is -3 squared? 9. Okay, we know that. We know -3 times -3 is a positive 9 because a negative times a negative is positive. People tend to put this in their calculator. Right? -3 squared. And you know what the calculator tells you? -9. Now, is the calculator wrong? You entered it wrong. Okay? The way the calculator reads it is, I want you to square the 3 for me, which is 9, and then multiply it by -1. Okay? So, just for a note, if you want to put it in the calculator, you got to put the negative sign in with the 3 in parentheses so the calculator knows to square -3 and not just 3. Alright, so now we got the square root of 25 plus 9, which gets me back to the square root of 34, which is what we found out before using Pythagorean theorem. Okay. And then we'll do another one with formula. So again, plugging into my formula. My distance, x, y, little ones, little twos. So x2 minus x1, y2 minus y1. Again, be careful of your negative signs. So it's 7 squared plus 5 squared. Which is 49 plus 25. 674. Doesn't everybody know how to enter the square root of 74 into their calculator? There's the square root button. Yes.
Does it matter which way you put the 2 x's in?
Not really. If you, because I could call this x1, y1, x2, y2 if I felt like it. All right, and let's just see what the square root of 74 is. So you can put the decimal there. All right, 8.6. All right, now I'm going to have you guys try 2, and I want to see if you come up with the right answer. Last thing I need to teach you is we did distance on a number line, midpoint on a number line. We did distance on a coordinate plane. Now we have to do midpoint on a coordinate plane. Okay? This looks kind of complicated. Technically, you can call it the midpoint formula. Okay? However, how did we say to find the midpoint on a number line? You average. You're going to do the same thing. Isn't average adding, dividing by 2, adding, dividing by 2? The only difference is you have an x-coordinate and you have a y-coordinate. So now you're going to average your x-coordinate and average your y-coordinate. And that gives you a point. So let's try it. That's what I just said. All right. So if I want to find the midpoint, I want to find the average. Okay, so here's my x's. Let's average them. -5 plus 2 divided by 2. So -5 plus 2 is -3 divided by 2 is -1.5. Then my y's, -7 plus -2, average them. -7 plus -2 is -9. Divided by 2 is -4.5. Okay? Now remember, the midpoint is a point. If we're in the coordinate plane, a midpoint should have an x and a y. So your answer would be, here's my x-coordinate, here's my y-coordinate. It should look like a point because it's the midpoint. It's a point actually on the grid. You're not going to add these, divide these, make them fancy. It should look like another x, y coordinate. Questions? Did I not, kind of copy a word? Yeah. Coordinate pair is that word from the formula. That's important because people sometimes like to combine those numbers at the end. You don't want to do that. You want it to be a coordinate pair, an x and a y. Alright, let's do it again. Again, if I want to find the midpoint, I want to do the average. So average means add them and divide by 2. So this is an x and this is an x. So I'm going to add them first to get -2. Divide by 2 to get -1. There's my y's averaged, I get 1/2. Again, my final answer should look like a ordered pair. And there's my midpoint. Questions on that one? Okay. So I'm going to make it a little fancier. Okay, they like to put these types of problems on standardized tests because you have to think a little more than just finding an average. So it says find the coordinates of P. If M is -2, 2 is the midpoint of PQ and Q has coordinates 2, 8. Okay, so for argument's sake here, so I can get a little bit of a visual. I know I'm not on a grid right now, and I'm not really making it that pretty here, but okay, and I know my midpoint. I just want to see what I'm working with. Okay. So I know M is in the middle. I know what the coordinates are. I know Q is one of my ends. I know what those coordinates are. Instead of missing my midpoint, I'm missing coordinates. So it's kind of like I got to go backwards a little bit, right? So I'm looking at this. And I know I have a rule. My rule for finding midpoints is to average, right? And what do you average? You average the endpoints. What's the problem with my endpoints this time?
You only have one.
I only got one. Can I still average with variables? Why not? If I want to average my x coordinates, 2 and x, right? I could still write it out. Average says to do what? Add them. And then do what? Divide by 2. The difference this time is I know what the answer is. When I average them, what number should I get? -2, right? Because that's in my x spot for my midpoint. I know I should get -2. Do you guys know how to solve this? What would I do first, David?
Multiply by 2.
Multiply by 2. So 2 plus x is equal to -4, and then what would I do?
Subtract 2.
Yep. So now I know my x coordinate is -6. And if you think about it, we're doing the opposite. Before we added and then divide, right? What's the opposite of dividing? Multiplying. What's the opposite of adding? Subtracting. So we undid our work. So that gives me the x coordinate over here. And then I just have to do the y coordinate. So I would repeat the process with my y's. So 8 and y. So 8 plus y divided by 2. Averaging. Add the two coordinates, divide by 2. What should my answer be this time? A +2. Again, we follow the same steps. To undo, divide by 2, we multiply by 2. So 8 plus y is equal to 4. And then I would subtract, so y is -4. Okay, and if we look at our answer over here for our missing endpoint, think about it. -6 and 2. Is -2 a number in between them?
Yes.
Yeah. -4 and 8. Is 2 a number in between them?
Yes.
So we look pretty good. If that's the most complicated, I'm going to make it. Working backwards to find the missing endpoint. We're going to do one more like that. Okay? Again, maybe I'm going to get a picture going here so I can kind of visualize it. Okay, so S is the midpoint this time. RT with S being in the middle. Okay, I know that S is negative 1, 5. That's my answer. So that's my midpoint. And I know that T is negative 4, 3. I don't know what this is, so I'm going to call it X and Y. Again, if I want the midpoint, I want to average. So my two X's this time are negative 4 and X. Average says to add and divide by 2. What should the average of my X's equal? Negative 1. And how do we know that? That's the midpoint or the average point. The X coordinate. And these are my X's. So we'll multiply by 2 to get rid of divide by 2. And then add my 4 to get 2. Okay, because it's a negative 4, so we want to add 4 to both sides. So that means my X coordinate, okay. And repeat it for your Y's. Your Y coordinates are Y and 3. So Y plus 3 divided by 2. What should my answer for my Y average be? 5. So to get rid of divide by 2, we times. So Y plus 3 is equal to 10, which means Y has to be 7. So here is your missing endpoint. Questions? Okay, one more in the rule. And it's not as hard as this one. Last one. If A is the midpoint of xy, ax is 2m plus 5, and ay is m 4m minus 11, find m and xy. Draw a picture. All right, so here we go. Xy. M is the midpoint. Remember we said for midpoints, you show it's a midpoint by putting those tick marks. Label AX. Okay, I put an M there. AX is 2m plus 5. And AY is 4m minus 11. Once you draw this picture, it should start to make a little more sense. Does anybody know what I would do to figure out what M is? Well, what do you see in the picture besides my equations? These things, yeah. What are these things called? Tick marks. What do tick marks mean?
Equal.
Congruency. Equal. So what do you know about these two then? They're equal. So what do you put in between two things that are equal? Sign.
Yeah.
That's it. If you see those congruent marks, automatically think set equal. Okay. Here's another thing to notice. The problems we were doing before, didn't I give you a total? Right. Did I give you a total this time? No, I only gave you these two and tick marks. So we're not going to add them because I have nothing to set them equal to. Okay? The tick marks mean congruent, which means they are equal measure. So subtract your 2m. Add your 11. So m is 8. All right, there's m, and then what would I do to find x, y?
You plug that 8 in.
Plug it in. All right. So 2 times 8 is 16, plus 5 is 21. So this side's 21. I don't even have to plug it in over here. What does that side have to be? 21, because they're equal. So what's 21 plus 21?
42.
So that's your x, y. Okay. And then one little vocab word at the end, bisect. Bi means two, sect is like cut. So bisect is to cut the two equal pieces. So that's what a midpoint does. A midpoint bisects or cuts a segment into two equal pieces. Homework.